back to exercise 1D and just the last bits of 1C, odd and even functions, and in 1D it was sums or addition of ordinates, both of which are very easy concepts, which is why we're going to do a bit of a break from functions as an idea of like what's inverse functions, whatnot. But remember, the hardest one is 1E, so over this weekend, can you please practice exercise 1E. I am going to make a video of myself doing exercise 1E, especially the last few questions. If you want to go ahead tonight, then you can watch 2018. I would have done the examples as well. You can watch that as well. But I'll do it this weekend and I'll post it up so you can see how what we did with the two conditions, how we're going to relate it to 1E and practice to master it. Yeah? But odd and even functions, open up your exercise books. We're going to copy these two definitions as to what an odd and an even function is. It's very simple. Copy these two. It's in the yellow box. Mathematical definition. Odd functions have the property f of negative x is equal to the negative of f of x. So copy that down. And even functions have the property of f of negative x is equal to f of x. In a nutshell, what that mathematical definition is trying to say is all it says is, if you want to know if a function is negative, an even or an odd function, it's very simple. If you sub in a negative number into that function, and the result ends up being negative of the entire function, okay, and that's considered as odd. Whereas if you sub in a negative number into that machine, and it throws out the positive of that machine, then that's even. An example, just to get your head around the idea of machines and chucking in a negative number, all I'm saying is this. I'm saying you got a machine, it's f of x. I have no idea what f of x is, but I'm going to chuck a number in. So let's say is a negative number. So let's say I chuck a -1 in. Okay? What's an example of an even function if I gave you x squared? See, if I chucked a -1 into the function, that's what this is saying. It's saying f of, what am I putting into the machine? I'm putting a negative number. I just don't know what that number is. It's just negative x. But it could be any number, -2, -1, negative infinity, I don't care. It's a negative number, right? But then when you put a -1 in as an example, what spits out? What's a number that comes out? 1. So -1 now becomes a +1, right? But the key thing here is when it goes in, it was when x equals to -1, and then when it spits out, it is f of -1, which is the same thing as saying just f of 1. There is no difference between the two. So whether I put a positive number in, or whether I put a negative number in, they're both the same. So if I put a 1 in, so if I chuck in a 1 now, so if I chuck in a 1, if I chuck in a 1, the answer is still going to be, I'm going to do it in blue so you can see the differences. If I chuck in a 1, I get a 1. But if I chuck in a -1, I still get a 1. That's why I can say f of -1 means when you put a -1 in, it's exactly the same as if you put the positive number in. They put a definition to this and they said any function that follows this rule is called an even function. Any function that if you put in a negative number and it ends up being the same as the negative of the function, then it is an odd function. An example, I'll give you another example here. So let's say the function was an x cubed. Okay? I have the option, if I'm going to put in a 1, so x equals 1 versus x equals to -1, right? I will have an answer where it will come out as f of 1, and I'll have an answer where it's f of -1. True? Now, out of these two, I'm just going to see if the answers are going to be the same or different. If it's the same, which is like this case here, both values are exactly the same. If you subbed in a +1 or a -1, it doesn't matter. And that's even. If you sub in a negative and it's equivalent to you just saying times the whole thing by a negative, then that's odd. Okay, so I'll show you here. So if we work it out, if I sub in a 1 cubed will give you 1. But then subbing in a -1 will give me -1. Now these two are different. But if I multiply, see, according to this definition here, It says if I put a -1 in, they gave me an answer of -1. They're saying, well, can you get the answer if you just multiplied the positive version by -1? And it's true, this is my positive version, that's 1. If I took this and I times it by a negative, they're both the same. See what I'm doing? So f of x, what is f of x? It's 1. And if I times it by a negative, it ends up being the same. This is called odd. This is called even. Okay? Now, if that was confusing by using numbers, I'll use letters. Normally in the previous years I teach with letters. This year I've just chosen to do with numbers. But let's do with just letters. And then I'll show you one where it's neither. Okay, so you can have odd, you can have even, and you can have neither. All right, I'll show you one that's neither. So, let's go back to the idea. If I had x squared, and I decided to put x into the equation, then what will spit out is it will be just f of x, which is x squared. Okay? If I decide to chuck in the second part now, I'm going to do it in red. If I decide to chuck in a negative x, then this now becomes negative x squared. Agreed? So that means now if I do f of negative x, it is equal to negative x squared. But if I simplify this, negative x squared, if you simplify this, what does this become? X squared. And it just so happens that f of the one in red, f of negative x, which is x squared, is also the same as the blue, which is f of x. And that fits this definition here. F of negative x is the same as f of x. Hence, even. Yeah? Same thing with the odd. Now if I do the odd, let's do odd, which if I change the problem to an x cubed, let's do an odd. Let's do an odd. So same drill as everything else that we just did. If I sub in an x into x cubed, then f of x becomes x cubed. If I sub in negative x into x cubed, then I would now have negative x all cubed. But what's the answer to this if you simplify it? Negative x cubed is the same thing as writing negative x all cubed. Then you look at this equation and you say, all right, f of negative x looks very similar to f of x. The only difference between these two, this doesn't have the times negative. That's what the second function is saying. See, it's odd. If f of x, the normal f of x, the one in blue, if I just times that by a negative, is that the same as subbing a negative x in? Then it's odd. So that's why this is odd. Now let me show you a neither, so then it clarifies everything. So when doesn't it work? When is it odd? When is it even? When is it neither? Yeah, I'll show you a neither and then everything will make sense. Yeah? I'll give you an example of a neither. Let's do x cubed and wait, that doesn't work. No, I just did something in my head there. Yeah, negative x squared. That should be a neither. No, that wouldn't be a neither. Sorry, plus. Does that make it a neither? Let me go negative, negative, negative. Yeah, okay, here we go. So, same drill. Let's say that was my function. Let's say that's f of x. So let's write out. If I put in x into the equation, then what will spit out is f of x is equal to x cubed plus x squared. True? Okay, so nothing has changed. That's just my equation. If I put an x in, then it's x cubed plus x squared, and that's what it spits out. That's my y value. If I now substitute in negative x, is what this is saying. We're going to check out if it's either one of these. Yeah? So put in a negative x. Put a negative x in, so what will I have? If I do, I'll do it in red so we can see. Here we go. F of negative x is equal to, I'm substituting negative x in, you cube it, plus substitute negative x in, and then you square it. If I simplify this, what does this become?
Negative x cubed minus x squared.
Very good. This would be negative x cubed. That's still plus, and the squaring of a negative becomes positive, so this is plus x squared. Now here's the first question. Is it an even function? If it's even, that means this answer should be the same as f of x. because f of negative x is apparently meant to be the same. These two are meant to be the same. But if you compare the two, are they the same? Well, that's an x cubed, that's a negative x cubed. That's not the same already. So that can't be even. This is not an even function. Then we test, all right, well, is it an odd function? If it's an odd function, apparently this red one should be the negative of the blue. So it's like negative of f of x. Now, if I put a negative in front of f of x, that means I'm saying put all of this as a negative. So negative of f of x, so if you write it over here, negative of f of x should be the same thing as saying negative of x cubed and negative of x squared. So if you compare this now, negative x cubed and minus x squared, now if you compare this with this, are they the same? Because that's what this condition is saying. This condition says negative of your f of x. That's my f of x. If I put a negative in front, this means put a negative in front of the whole blue equation. That's what negative f of x looks like. And I compare this with this, and it doesn't match. Because they don't match, it's not an odd, and neither is it even, so we call this neither. So the whole exercise of that part with 1c, where they ask you to prove whether it's an even or an odd function, all they want you to do is literally what I just did. We test out f of x, we test out f of negative x, and then we test out negative of f of x, if they're equal or not. If they're equal, then you can determine one of these, and if they don't equal, then it's neither. So this is an example of a neither function. It's not odd or neither is it even. Okay? What's the most confusing one of this sort of concept? It's the odd. Okay, because of all the notations. So remember I told you that in functions, what's scary to students is not the concept I'm talking about. We're just comparing two things. Are they the same? If they are, great. They're not, they're not. Right? What's hard is reading what it's trying to tell you. Reading the set notations. Okay? Any questions about the odd even that you're unsure about with the negative of f of x and you're just comparing? Because in the next slide I'm going to get you to practice. Okay? And then once you practice that, we'll go to addition of ordinates and bam! We're done for 1C, 1D. Go home and practice 1A, revise set notations and range domain and what a function is. Okay? Any questions? Good. All right, here we go. Your turn. I put up on the side here the definition if you didn't copy it down. I want you to tell me in your own exercise as you work through them, I want you to prove which ones are odd, which ones are even, and which one are neither. Okay, have a go with these ones. Go. There we go. I'll give you, it's currently 11:13. I reckon it shouldn't take more than, how many? 1, 2, 3, 4, 5, 6. I'll give it about 5 minutes. Okay, so 11:18 we'll stop. Let's go. 5 minutes. Have a go. You'll start to pick up patterns. You won't even have to do the test as I just did to figure out. You pick up patterns. You square it, it moves a negative. So look for certain things. How do you know if it's odd, even, or neither very quickly? What are you really looking for?
Literally anything else.
What? What was your initial first name? Yeah, exactly. Oh wait, are you saying that? They'll figure it out. Oh no, that's all because the logic to this is we draw both the graphs.
Just because if you have a negative x, it's 1, 2, x. Oh wait, no. Because x on 3 is still negative. Yeah.
Is it C odd? I'll say on if you put minus 1 in, it'll be minus 1 times by minus 2 equals positive 2.
Yeah, and then if you put 1 in, negative 2x and then
But that's not like you don't put 1 in, you put negative 1 in.
yeah, you have to put 1 and negative 1 in. That's all we need to know.
Negative function.
If you put x in,
Saying if you put any negative, the rule is if you put any negative x value, then it has to be. I don't know why you would put a positive function. Sorry? Just follow that rule. So if you put any negative x value in that, will be the whole equation will be negative, right?
so D, if you put negative x in, it's 1 negative x.
Which one D? Yeah, it's odd. Because if you put negative 1 in, it's negative 1. If you put negative 2 in, it's negative 1.
This is where it gets tricky. You got the ball. At this point, they both that's doing minus the whole year. But it does mean this is also if you were to add this extra text, it's always plus.
They said same thing. Which very much yeah, they think it's either benign or that there's brain pressure building up. So they're sending me to a he specializes in brain and spine. It's a neuroscientist. It's not northeast.
Ready at the center. Get sealed up. I'll start this top one. Like this can. And as I move going forward, you get closer and closer. Before this number, you have to be less than this. And so it has to eventually it's so small. That's not oh, so that makes it. That works out. Go in there too. Then also you have to analyze what's line. That means this is infinite. This is this line. This line is out in there. Yeah, it's easy, I think. But, you need it as well. No, like we're still adding the white ones. Put in one. What is he doing? Yeah. Yeah. And that's why I swear so. This is my look so negative.
The same as
Somebody here.
each time that by
Summon 1 was negative 1 and summon by negative 1.
not understandable. What's just said it not it doesn't matter either way it works as long as you submit to me.
Yeah, because when it's even, there's no negative consequence. So when it's odd, you add a negative.
That's really
Okay, so thanks for the
No, but if
yeah, I get you. I'll do it like this. Oh, okay.
It doesn't matter. You can sub in a number or an answer.
I don't know.
I think it's odd.
No, I don't know.
How did you get
I'm just really bad at that. So
Odds on left should be
I back this up. It's probably right. No, you're probably right.
but how did you get about
I know, but I'm doing it now.
Which one?
nothing, okay? You're in a world of your own. Lily.
Sorry?
I'll do it right now. I'll do it right now. I'm still right.
Also odd, it's neither.
How did neither go?
Because if you put minus, we call it 5,
I
then
think
we call
it
it.
is neither. Right.
Yeah, it is neither.
How does it neither go?
Because if you put a number like 4 in it, then also like if you put, sorry, wait,
I just something.
what I did.
Isn't that the same?
That's the same as that. That's not.
How did you put a negative in front of here? Yes, you do. That's what I think we're talking about. You copied it down wrong. It's 1 over empty minus.
Oh, I think it's your mind though. I think it's what? I'll try it again. I think I'm right.
All right. I went a bit over time. I had 3 minutes extra. Check your answers. So the first one, A, I tested by subbing in negative x into the x squared becomes x squared plus 7. So what you should notice is because we're subbing in negative x to test, anything that's squared is always going to be positive. So if you already see that there's only one squared, it's likely to be even because every time you put a negative number, it's always going to be the same. So that one is still equal to the same as A. So x squared plus 7 is still the same as x squared plus 7. So therefore, f of negative x is the same thing as f of x. So therefore, it is even. Okay? So therefore, hence it is an even function. Same thing with C. Let's jump on to C. I'm just moving around here. So f of x, if I sub in negative, notice it's a cube. Cube is always going to make it, if you put a negative, it's going to end up being negative again. So you should already look at that and say, well, if it's going to be negative, it's not going to look the same as f of x. So it can't be even. It might be odd. So let's test it. So if I sub it in, I end up with positive 2x cubed plus 7. But remember, we want this to equal to the negative of f of x. So if this is f of x and I put a negative in front of it, it just means this becomes a positive and that becomes a negative. So it ends up being 2x cubed minus 7, which is different to what I have here. Okay, so I did it in the next step. I wrote here, negative of f of x is different to f of x, therefore it is a neither. Okay, so if you're confused what I just did there, see f of x is currently negative 2x cubed plus 7. We're testing negative of f of x. Negative of f of x just means times this whole thing by a negative. That's what it means. That's f of x times it by a negative. So if this is f of x, times it all by a negative. So if I times that by a negative, I get 2x cubed. If I times the 7 by a negative, I get minus 7. And now I compare this with this. Those two are different. Because essentially that's what the definition is saying. It says f of negative x, compare that with negative of f of x. And I can see that's 2x cubed plus 7, whilst this is 2x cubed minus 7. Therefore they're different, and hence it's not odd. And I know it can't be even already because of the negative at the start. So therefore it's neither. Does that consolidate a bit of the understanding? Yeah. So with that section there, it's only 2 definitions, and you just got to stick with that. Okay, and that comes up quite a bit. When I say quite a bit, it means like there's only one part, like a SAC or something, or in an exam question, they might just say because it's an even function, you need to know those properties to be to stay attuned or at least attentive of the domain, because that changes the domain. If it's an even, it means it's symmetrical. So it means if you know the coordinate of one side, you know the coordinate of the other side, if it's an even function. Okay? If it's an odd, then if you know the value here, then it's the inverse, which is on the other side. That's why it's important to know. Okay? But it doesn't come up as often, but you just need to know those 2 properties there. Even, odd, if it doesn't fit either, it's neither. How do we feel with that? Pretty good? All right, that's exercise 1C. There's a set of questions that you can practice if you want to do more of them. Otherwise, the PowerPoint's there too. Okay. Anyways, what's that? ABC. Now we can do that another time. I was going to revise functions, types of relations, many to one, one to one, all those, and then horizontal line tests, vertical line tests. That's what I was going to revise. But let's do 1C. I mean 1D. Where's 1D? These are the questions. Hybrid functions. Where's 1D? Come on. Oh, we go. All right. For today, 1D. There's only one thing you need to know, and that's what I'm going to work with. Just one extra property. Here we go. What is sums and product of functions? Very simple in terms of notation. Sums means add. Functions we now know we call f of x or g of x or p of x or t of x. If I have f of x, which is one function, and I add with another function g of x, you can write it as a notation as bracket f plus g in function of x. So bracket x. That is the same thing as saying f of x plus g of x. Okay? That also means that you can do subtraction of functions as well. It's just that we don't do that. We call it sums because you can change, instead of writing f minus g of x, this is the same thing as saying f of x plus the negative of g of x. That's why. We always like add. Add is always just nicer to work with rather than to take away. Okay? That's why they stick to sums and products. Okay, I mean, you can say difference of functions if you want. It's just sometimes it's a bit trickier. Because if you take a -1 and then minus a -10, you've got to remember that double negatives make a positive. So it's a bit harder to work with, that's all. Okay? But anyways, so what you need to understand here, and it's the very only one concept to take out of it. When you say sums of functions, I've got f of x and g of x. What is f of x again? Think about the machine. I've got an x. What is f of x representing again? Anyone remember? What's f of x represent? So if I said f of x equals x squared, what's f of x? What's it mean? It's a function, but on top of that, something else. Something more special that's very obvious, but we don't seem to see it. What else? You see it more so when you were in year 8, year 9, maybe year 10, and then as you get to year 11, we started using f of x and you forget what f of x actually means. The y values. F of x is the range. You see, think about it. You used to write this. You used to write y equals x squared. So if I asked you what is y, you're like, it's the y coordinates. I'm doing exactly the same thing as what I just said now. I just said f of x equals x squared, and I said, what's f of x? And you're stumbling. Because the meaning behind it, just, you lose it. It means the exact same thing. If I wrote f of x equals to x squared, this just means if I put in an x, which is the domain, it spits out whatever x is, or whatever the function does with x. This is your y values. That's your x values. So why am I emphasizing that? Because when you say this, when you say f of x plus g of x, what are you actually saying? You're really just saying, take the y value of the first function plus the y value of the second function. That's all you're saying. That's essentially all you're doing in 1D. Sums of functions just means add the y values. Products of functions just means times the two y values together. And then predict what it looks like. What's the skill in 1D? It's very highly skilled in the sense of analysis. Analyze what you have and predict what the overall answer is based on addition, subtraction, multiplication, division. Okay? In our case, it's just addition and multiplication. So let's do a quick example. I'll do a quick example, and I'll get you to even figure out the first property because it's very obvious. Here we go. I'll give you the first property of first example. Now remember, if I'm saying adding means, sorry, if you're adding, obviously you have to have two things to add, true? So let's say I gave you this. Let's say I said h of x is equal to the sum of a 1 on x and a root of x. Okay, so I've got two functions there. Let's sketch both of them so that we can see what's actually happening. So 1 on x, what does that look like? This is what it looks like. Rectangle hyperbola with an asymptote at x equals 0 and an asymptote at y equals 0. That's 1 on x. Then let's sketch now square root of x. Here we go, square root of x, inclusive of 0. Anyone know where the intersection might be? 1. Because if I do 1 on 1, it's still 1. And if I do square root of 1, it's still 1. So I know the intersection, logically, 1, 1. This is for root of x. Okay? Now I've got my function there. Now on a logical basis, remember we said take the first one, add with the second one. What are these representing? It's the y values. First one is the y values in red. Second one is the y values in green. So logically, this is a red dot here. So if I took out this y value, if I just looked at this dot right there, this dot, and I said I want to take the red and I want to add with the green. Is that possible? So what does that mean? You don't have a range when x is equal to this point. So whatever x is, let's say x was, I don't know, let's say -1, right? If x was -1, then the red one would be -1, -1. That's easy for the red one. But if I sub -1 into the square root, it's undefined. So how do you get this point plus an undefined? It doesn't work. So you're right, it doesn't have a range. What doesn't have a range? H of x. It means that if I asked you to sketch h of x now, I already know it doesn't have any negative numbers. Why? Because this one is only in the positive region. There is no negative numbers. So where can you add? What's the most obvious thing? When can you add? What's the requirement? That's the first problem. What do you need in order for you to add two y values? What's the first thing you have to have? Yeah, they have to have the same common domain. Because if they don't share the same common domain, this one says, I'll take all the negative x values, and the other one's like, no, I don't take it. It's like, how are we going to add? If I have $10 and you have no money, how are we going to add? If you're like, I don't have my bank with me, I don't have any cash with me. I'm like, cool, I've got $10, how much do you have? It's like, I don't have cash with me. It's like, how much do you have, man? Well, we're not going to get anywhere. If you have $2, I have $10, okay, now we've got something. So you can't add unless we both have something in common. We both have cash. Yeah? If you have a PayPal account and I've got cash, well, we can't share right now. I can't share it. We're in a restaurant, I'm like, I've got $10, and it's like, I've got PayPal. I'll pay $5. You can't do that unless one day we somehow can do PayPal and just pay waive it, right? But my concept, what I'm trying to teach you here, is 1D is very easy. What's the first property? In order for you to multiply each other or add each other, the first thing is they have to share the same domain. And that's the first property. Very easy. I'll show you on the next slide. The next slide after that. That's it. That's just the one property you need. Domain of the first function needs to intersect, which means they have to have in common the domain of G for any sum or multiplication. Because we just proved just now, how do you add or multiply two y values if they're not even there together? So it makes sense that the domains have to be the same. So write that property down. That's the only one thing you need for 1D. After that, what's the harder part? Is sketching. And that's what 1D is about. Okay, so 1D is tedious. It's not hard in what I'm explaining. It makes sense to just add the y values or times the y values. What's hard about it? You're going to take your time to think about it on each side. So when do they equal? When don't they equal? When are they more positive? When are they less negative or more negative? And then you predict what the graph looks like. Okay? Yep. That's a good question. When it first came out, sums and products of functions, it was tested all the time. And then it was a realization, one, it takes too long. Two, it's hard to mark. And so they started abolishing it from the exams. But you still have it though, that you have to identify that they have the same. So they might say, these are sums and products of these functions, define the domain. So it means like, where can you add them? So that's the first property. And depending if it's easy or not, they may give you one where there's only 2 marks for it. So make sure that the asymptote's correct and make sure the starting point's correct. So as long as you get those 2, then voila, you get 2 marks. So it depends on which functions. But back then, yeah, they used to have all like a cubic. Oh no, so they had not a cubic, that's a sine graph. They had a sine graph, add with a cos graph, and find out what sine x plus cos of x looks like. That was a common one. So you have to find x-intercepts, y-intercepts, intersection points, and it was a tedious one for just 3 marks. Might as well move on and get somewhere else, get another mark somewhere. But they've thrown that away now. But doesn't mean that they might not pull it back. I just haven't seen it for the last 10 years, so you never know. All right, here we go. Let's start by sketching. So I taught you the theory Sums and products, I taught you the theory of odd and even functions. Now it's the practicality. Right, so let's go back to my problem before. I gave you y equals to 1 on x plus root of x. I don't know what that graph looks like at the moment, but I'm going to try to predict it with you, okay? And we can use our CAS to predict it as well. But the skill here is to analyze what is available, what isn't, and what happens in the long run. Okay, so here we go. I draw the axes, and I'll draw the graph again. So we had asymptote, asymptote. Let's do the blue line for the square root function. There we go, and we know that this crosses here at 1, 1. I'm going to use purple to predict what the shape of the new graph should look like. So if I wanted you to sketch this equation, okay, because I sketched them individually, the red one's 1 on x and the blue one's square root. What if I want them together? I want the sum of these two functions. What does it look like? Let's start predicting. How do you start predicting? Find some things like x-intercepts. Why x-intercepts? Why am I looking at x-intercepts? Someone explain to me why. Why x-intercepts? What's so special about x-intercepts? Yeah, and remember, what are we doing? We're adding y values. So if you know you're adding on 0, it's just where it starts. So if you think about it, this is 0, but yet it's undefined here, so there's no point. Okay, so we don't need that point, so there's no x-intercepts there. But for other graphs, look at x-intercepts, because you always know it's going to be a y value of 0 plus whatever the other one is. Okay? Intersections is another beautiful one. Why? Why is the intersection a nice one? Yeah, it's double. Because they both have the same y value. At this point, the blue graph is 1. The red graph is also 1. So 1 plus 1 is just 2. So I already know this new graph has to have a point at, whoops. Oh, is it the other way? Uh-oh, there we go. It has to have a point at 1, 2. Because I know it's going to double. So any intersections in your graph, like especially the one where I talked about sine x plus cos x, find the intersections and just double them. Double the height. Whatever the height is from here, just double it. That's what we know. We know it's doubled. What we don't know is, does it go down or does it go up on the right-hand side of that point? And does it go down or does it go up on the left-hand side? That's what we don't know. But we can predict. Okay, so from here, let's predict. Let's say I chose this point here, this random point on the red line. If I chose this point, and I chose this blue point, and let's analyze. As I move this point, which I'll do a dotted line so you can see, this is where x is. If I started choosing all these points closer and closer towards 0, the red graph is getting infinitely large. What's happening to the blue graph? Infinitely small. So let's put it together. Red is getting really large. Blue is getting very small. Now, if I add those two numbers together, a very large number plus a very small number, what's your overall answer? Yeah, a pretty large number. It'll be a bit larger than the red, because the red one's like, let's say there was 10, then I'm adding on 1. Then it's 11 now. 11's bigger than 10. So that means it has to, from here, it has to go towards the red. It has to grow with the red, because it's always going to be following the red and adding a bit more. Add a bit more, add a bit more. So the red is always going to be there, and it's always going to be a little bit more, because we're adding just a little bit more there. True? So I know that from this point, it should start going towards that. What I don't know is, does it dip before it goes up? Now, why do you think I'm suggesting there might be a dip? Yeah, because somewhere between here, so they're both 1s, is there a point where the one is still larger than the other? Okay? Is there a point where one of these is larger than the other? That's where derivatives come in, and you can sort of test that. Or you can keep testing a couple of numbers to guess whether it dips down or not. And this is the whole point of 1D. The questions they give you, you're not meant to be 100% accurate. You're only meant to predict roughly what the graph should look like. That's all you can do. That's the best you can do, right? So if you look at this one, let's look. We know that it's going to go towards the red. That's one thing we know. We'll check out, we'll go into this other side first before we come back and check if there's a dip or not. Well, let's have a look on the right-hand side of this. Okay, so all I know so far is it's going to follow the red. That's all I know. I don't know if it's going to dip down or whether it starts here and it just goes up. I don't know, okay? Because if it goes up, it means that this plus this will make it larger than 1. And I don't know that. Because I know here's 1. But what if this was like 0.8 and that was, I don't know, 1.1, then it's just 1.9 and it's just less than 2. See what I mean? So if this was 0.8 and that was 1.1, adding those two is 1.9. That's what I don't know. Okay? So it could just be a bit lower or maybe it's a bit above. Right? Now let's look on the right-hand side. What's happening to the pattern on the right-hand side? What's the red graph approaching? What's the y values approaching? Smaller. The red graph is getting smaller and smaller and smaller, yet the blue graph is always, even though not as fast as the red over here, it's bigger compared to small. So if you're getting something like blue adding on something very small, it's always going to be a bit bigger than the blue. So therefore, I know that eventually it's going to follow that. So what my prediction is that whilst it doubles here, it's likely that it's going to have this sort of parabolic shape where I don't know where the turning point is. The only way to find out the turning point is find the derivative, let it equal to 0. Okay? But at least I can tell you that overall, this is what you should expect in that shape. Now let's test that. So on your CAS, if you have a CAS, I'm just going to open up my CAS and I'm going to get you to see if that's true. And that's the skill. So what was I using? I was using x-intercepts, intersections, and then I looked what happens when I go more positive, what happens if I go more negative. Your job is to look overall, what should it roughly look like? That's your skill. That's for 1D, okay? Here we go, let's sketch. And then you guys can have your time to do 1D and 1C. All right, here we go. Menu, define f of x equals to 1 on x. For those who didn't use this last year, get in the habit of start defining your equations because it makes it easier to do, you know, like you're solving for applications. So we go. I'm going to sketch the graph, add graphs. Here we go, f of x. I've got my blue graph. I'm going to do g of x. There we go, that's what we drew. And we predicted that it should follow the blue and it should then follow the red. So let's have a look. If I do f of x plus g of x, voila. There you go. Exactly what I was predicting with the graph, that it should follow that concept. Okay, so the aim is to approximate what it should look like. That's what you're trying to do. Okay. How do we feel with that? That's, like I said, it's not a hard exercise, it's a tedious exercise. It takes a lot of analysis, time, and prediction, and each little thing you have to look at in terms of graph in order to do it correctly. Okay? That's 1D, you got 1C, and then we'll come back on Monday, we'll do 1F, which is inverse functions. Okay, but please learn 1E. Please learn 1E. Wait, I'm just going to pause the video.